What's up? I don't know if you guys can hear me. Hello? If you guys can hear me, say something. Well, I can hear me, so I guess that's all that matters. All right. As I told all you guys, I'm gonna do some of these questions. I'll do most of this math. I'm just gonna go through it. If you guys have any questions, just write down which number, and then at the end, if any of you guys have questions, I'll go back and try to answer that, so you guys can just type it into the little chat box or whatever. And then, yeah, I'll answer that stuff at the end. And then if nobody has any questions, then I guess, yeah, you guys can just take the test tomorrow. And yeah. All right, so I'm gonna skip these first few questions. Honestly, most time we're pretty good with these, so I just don't feel like talking about every single question. So yeah, so the first one we're actually gonna talk about is number 5. So number 5 is an absolute value. And how I always think about absolute values is we just think what the inside is going to be. So a lot of people are like, oh, X has to be positive. Nope, it's not that X has to be positive. This inside stuff can be negative. It's the outcome of the absolute value is going to be positive. So all we do, absolute values, is we set the inside equal to both the positive and the negative of the right side. So that's all I'm doing here. So we're just going to solve for X. We'll add 1. So we get X equals 9. We'll add 1. Say X equals -7. But if we pay attention to the question, it says, what is the possible value of X minus 1? So since we know what X minus 1 is, we're just going to plug X back in. So we'll say 9 minus 1 is 8. Well, 8's not an answer, so we'll try -7 minus 1. -8, boom. -8. So absolute values, you set the absolute value equal to both the positive and negative of the right side. All right. That's number 6. So this is a question where they give us a graph, and then they're asking for the equation of the graph. So they're saying, what is the graph of the linear function f is shown? Which equation defines f? So I'm going to talk about this problem 2 ways. One way is to do this like we do lines with the graph, which a lot of times we just kind of count the slopes. So we just say slope is rise over run. So we're going to just start at a point. So I'm starting at that y-intercept right there. So we're going up. Oops, why is it erasing? So we're going up 1, 2, 3. But if you notice, those intervals aren't by 1s, they're by 2s. So we actually went up 6. And then to the right, 1. But again, the x-axis is by 4s. So our slope is 6 over 4, which we will usually simplify. So 3 over 2. So we now know that our slope should be 3 over 2. And then I would notice that all of these answers are just written as y equals mx plus b. So just remember, f of x is a fancy way of saying y. So we know the slope should be 3 over 2. So C and D are out here. And then actually, since the point, one of the points that I start with on the graph is the y-intercept, that's what the b is. B, remember, is the y-intercept. The y-intercept is just -8. So the answer is A. Now remember, y-intercept. Most of the time when we think of y-intercept, we want to think that it is the value of y when x is 0. Now for this problem, we don't really have to think of that, but for future questions, we may see that they're saying y-intercept, which means we're going to make x 0. All right. So number 7. It's another one that I would notice that just is a line. And the problem tells us that a research institute conducted phone and mail surveys. The total cost of conducting these surveys was $5,000. The line shown models the possible combinations of phone and mail surveys that the institute could have conducted. Okay, so they're, no matter what, it's $5,000 based off of however many mail surveys they did and phone surveys they did. But then the question down here wants to know, according to the model, what was the cost for each phone survey conducted? So how I think about this problem is I just don't care about mail surveys. They didn't care about the price for mail surveys. So we're going to think, okay, I just want to know phone surveys. So to just think about phone surveys, we want to pick a point on this line where we can basically say, hey, mail surveys don't exist anymore. So we're actually going to pick this point, because that right there is telling us that there were 0 mail surveys, but then there were 125 phone surveys. So all the money that we paid was purely for phone surveys. Well, so since it is 125 phone surveys, we would multiply that by whatever the cost is. So we'll just call it P. P is the cost for the phone surveys. And that should equal the $5,000. So now we're just solving for P. So we'll divide by 125. And then this is where, honestly, this problem gets quite hard, is just because of the math. So how I've explained this in the past is you could just try to simplify that fraction. So maybe we recognize 5,000 and 125 are both divisible by 5. So then we can just slowly simplify this fraction. And now I know both of those are divisible by 5. So that's 200 over 5. So now 200 divided by 5 is a little bit more doable. So we can say 40. We could also really try to do long division, but I know a lot of us aren't big fans of that, so we don't have to do it that way. All right, you could also actually plug in the answers and guess and check. Once we got to this part where we knew this had to be true, you could just take those answers and plug in and guess and check. My sister just commented saying where are her students at. There's only 5 people here, so there may not be any of your students here. All right, so number 8. Which expression is equivalent to 5x cubed minus 2x plus 1, all minus 2x cubed plus 2x plus 1? So for this problem, the mistake that people do is they FOIL this. We're not multiplying these two parentheses. We're just combining like terms. We're just subtracting them. So I just kind of go through and just say which terms are alike and then do whatever the signs are. So I actually treat this as I'm going to look at this 5x cubed minus 2x cubed. So 5 minus 2 is just 3x cubed. And all the answers have that, so that didn't even help us. So then I just go to the next one. So I notice I have negative 2x. So I have negative 2x minus 2x. So negative 2 minus 2. Those don't cancel because they're the same sign. So it's negative 4x. And then we have 1 minus 1. So 1 minus 1, of course, is just 0, but we don't write that. So C. So just combine like terms. Cool. All right, so this next question. Again, this is where we're starting to get to some problems that tend to get a little bit more difficult. So they tell us that triangle ABC and triangle DEF each have 2 angles measuring 35 degrees as shown. Which of the following additional pieces of information is sufficient to prove that triangle ABC is congruent to triangle DEF? So first off, let's just define some things. So what is it? Let's talk about what is similarity, saying triangles are similar mean, and what does it mean to be congruent? So similar means the same angles. So if you have 2 triangles that are similar to each other, all 3 of their angles from one triangle will be the same as the 3 angles in the other triangle. So there's corresponding angles within each triangle. And one of our ways to show that 2 triangles are similar is to say that they have 2 angles are the same. Because if 2 angles are the same, the third angle has to be the same because all angles in a triangle will eventually add up to 180. So since for these 2 triangles that they drew for us, they have 2 angles that are the same within each triangle. So that means their third angle here is also going to be the same. So we already know that these 2 triangles are similar. Now for this problem, that is not what we need to know though, because they want us to be able to say these two triangles are congruent. So to say triangles congruent, it doesn't mean that the angles are the same. It means that the triangles are the same, which actually I guess the angles are the same. So, but the angles aren't the only things that are the same. The angles should be the same and the sides. So in order to ever say that two triangles are congruent, we're going to have to say something about two of their sides being the same. So I know for these answers, to be able to say these triangles are congruent, we're going to have to mention something about the sides. So A is talking about angles, so no. D, no, we need more information to prove their triangle. To prove their congruent triangle, excuse me. So now it's between B and C. So B says the length of BC, so that is this side, is equal to EF. And then the reason why that would then be our answer is because those two sides are the same and they're in the same part of each respective triangle. So we now said that they have two sides that are the same. Just talk about C because C definitely doesn't really make a lot of sense. They're saying for answer choice C that AC would equal ED or DE. And we can just see that those two sides don't correspond with each other. So if they're the same, there's no way these two triangles would actually be the same, aka congruent. So again, congruent just means the same exact triangle for everything. All right. So then number 10. So having to deal a little bit with exponents. So here I would notice that I am multiplying. I have an exponential raised to another exponent, which means we're going to multiply these two numbers. Multiply those two exponents. So I'm just going to write y to the 8th. And it's time y to the 9 over 8. And now I would notice that we're multiplying things with the same base. So if we're ever multiplying things with the same base, we add the exponents. So this is just going to be y to the 10 over 8. And then we just can simplify this fraction. I would notice that none of the answers have a 10 in it. So that exponent can simplify to 5 over 4. And remember, the number on the bottom goes outside. The number on the top goes inside. The way I think about it is 5, the number inside is the power. And I always think whatever is on top is in power. So that is the power. So that is going to stay as an exponent, an exponential power. So yeah. So the answer is A. Cool. All right, number 11. I'm not going to really worry too much about this. This is knowing unit circle. So if you have taken pre-calc or trig and you know the unit circle, or you're like, oh, I learned it once and I forgot it, look it up. If you're really that curious, this is not something you're super likely to see. They've done it like a couple of times. So here, sine of 3 pi over 4. Anytime you have 3 pi over 4 or pi over 4, basically 4 in the denominator, it's going to be either square root of 2 over 2 or negative square root of 2 over 2. And this one's just positive. So yeah. All right, but again, I'm not going to worry about that. All right, so number 12. So we're going to do this problem two ways. Just like I said earlier, and actually I don't think I did the earlier one the second way, but we're talking about a graph. And this is very often on the no calculator. So whenever they're talking about a graph on the no calculator, very often we can get away with not knowing actually how to graph whatever equation they're talking about. And here, this is an exponential equation because the variable x is in the exponent. So that's why it's called an exponential. So, but a lot of us don't really feel super confident graphing exponentials, or we don't know how that negative sign works or whatever. And I always say we don't really need to know that for most of these problems when they're on the no calculator or even on the calculator potentially. So the way that I often tell people how to do this problem is to either pick points from the answers. So here, these graphs, they all have a bunch of points on them. So we just pick points from all those answers. Or since they gave us the equation here, we can make our own t-table. So I'm just going to pick my own values for x, and then I'm just going to plug them into the equation and figure out what the y should be. So I'm not actually even knowing whether this graph is going to look like this or whatever. I don't really care. I'll just kind of figure it out once I figure out the dots, the points. So the most common one we usually pick is we say 0. So then I'm just saying, okay, well, 2 to the negative 0 plus 1. Remember, anything to the power of 0 is 1. So 2 to the negative 0 is still 1. So this is just 1 plus 1, so we end up getting 2. So the 0.02 should be a point. So if I want to, I could look at the answers and I would just, okay, A has that point, so A is still an option. B does not have that point, so B is out. C has that point, and D has that point. Okay, so we were able to eliminate one answer. That's why for a lot of these, 2 points is what we usually need. So we usually need 2 points. So we could just say, a lot of people pick 1. I'm going to pick -1. The reason why I'm going to pick -1 is because since x is already negative up here, I want to get rid of the negative sign. So this is just going to become 2 to the -1 plus 1. So those two negative signs cancel. So it's really just 2 to the first power, which is 2. So 2 plus 1 is 3. So the point -1,3 should be on there. And if I look at A has that point. B is already out. C does not have that point. And D does not have that point. So the answer is A. Which is why picking 2 points is usually the preferred method that we go with whenever we're trying to like pick points and guess and check. Because if 2 points work, that's probably going to be the correct graph or the correct equation for that graph that we're looking for. Now, the more mathematical way to do this is to know the generic equation of a exponential. So an exponential's equation, like kind of standard form of an exponential, is something that looks like this. So I'm just going to talk about this number at the end, the C. This tells us the asymptote. Tells us where the asymptote is going to be. And an asymptote is a line that the graph approaches but never quite touches, nor does it cross. And the asymptote is just going to be at y equals to whatever C is. So for this problem, I would notice that the C value is +1. So we should have an asymptote at y equals 1. So if we look at choice A, if we were to draw a little dashed line, it does look like this graph approaches y equals 1. Now, again, it looks like it touches it, but that's just because we can't zoom in enough. But all these other answers, if I draw an asymptote, they all cross that y equals 1 asymptote. That is the quicker way to be able to do some of these exponential problems where we're trying to graph them, is to maybe recognize the asymptotes. Again, I really do like picking points. It allows you to not really have to feel like you have to know how to graph exponentials and still get most of these exponential questions correct. But knowing the asymptote can make this problem a little bit quicker. So I just want to emphasize this. The number at the end, this one, is not your y-intercept. It is not your y-intercept. Because remember, your y-intercept is the value of y when x is 0. So that number at the end for an exponential will never be your y-intercept. And this whole picking points and plugging in can work with almost any graph. So it doesn't have to be exponentials. It could literally be any graph. All right, so 13. So now dealing with percent change. So it says in 2005, 10 phlox plants were planted in a garden. The number of phlox plants increased by 140% each year. Which of the following equations best models the estimated number of plants P in the garden T years after 2005? So almost, if you ever see something where they say percent change, you're probably going to do the percent change equation. So the equation that I usually go with is the initial value. Let's go back to the red. So I usually say it's the initial value times 1 plus or minus r, where r is our percentage, but as a decimal. So I is the initial, 1 plus or minus r. The reason why it could be plus or minus because we could have an increase or decrease. Now here we're having an increase. But here we're saying, what is our I value? It is 10. We started with 10 phlox plants. We increased by 140%. Well, 140%, we could just say, hey, let's move that decimal place twice. So 1.4. So then it's 10 times 2.4. Now notice for all these answers, they have the power t. I honestly wouldn't really pay that close attention to it because every answer has t. So who cares? Yeah, that t is there because it happens once a year, I guess. But I honestly would not pay too close attention to that. So the big thing is understanding and remembering the percent change equation. It's the initial value times 1 plus or minus r, which is our percent change as a decimal. And then usually we're just simplifying that. All right, so question like number 14, something that's been showing up more often over the last few tests. And that is where we're having to do translations of some sort. So doing some sort of translation. So they gave us this function. It says the complete graph of the function f is shown in the xy plane. What is the y-intercept of the graph of y equals f of x plus 2? So we have to recognize that this x plus 2 is happening, the plus 2 is happening with the x, not outside of that parentheses, so separate from the x. So that means that this shift is happening horizontally. So we just got to decide which way is it moving. When it's in the parentheses, we always shift it the opposite direction of what the sign is saying. So here it says plus. We're not going to move it to the right. We're going to move it to the left. And what I just do for this question is I'm just going to take literally every point and move it to the left too. So I'm just going to take this point and move it here, point here, there. It's going to go here, here, here. No, I messed that last one up. No, I messed up a few of those. There. And then we can kind of see it's going to be this graph now. Boom. You can do the sound effects if you want when drawing it. So yeah, so they wanted the y-intercept. So now we can see with my new graph where our y-intercept is. So the y-intercept is where it crosses the y-axis. So it's right there. So it's at 0, 3. Cool. All right, I'm not going to do the other way. I like that way. All right, so 15. So you're going to have this question almost guaranteed tomorrow when you take the test. It says one of the two equations in a linear system is 2x plus 2y equals 2. The system has no solution. Which equation could be the other equation in the system? There are multiple ways to do it. How I have been explaining this question is to go ahead and write all of these lines in y equals mx plus b, because whenever they say no solution, that means that those two lines have to have the same slope and a different y-intercept. Now, I know that this way of doing it is a little bit longer compared to potentially doing it other ways, but I feel like we tend to make a lot more mistakes trying to think of the other ways compared to this, because this just fits every single time. If you're talking about two lines and you're talking about the number of solutions, then that means we can write them as y equals mx plus b, and then compare the slopes and the y-intercept. So the slopes are the same and the y-intercept is different. That is going to be no solution. If the slopes are the same and the y-intercepts are the same, that's going to be infinite solutions, because they're literally the same line. And then if they just have different slopes, we can actually ignore the y-intercept at that point. If the slopes are different, it's going to be one solution. So they've asked for all of them before, or each one at some point on a test. So here we're going to start with the original equation. So I'm just going to do it over to the side. So that 2x plus 2y equals 2. So I'm just going to write it as y equals mx plus b. So we'll move that 2x over. So I'll subtract it over. Now we have 2y equals negative 2x plus 2. And we're going to divide everything by 2. So y equals negative x plus 1. So here I would notice my slope is negative 1 and my y-intercept is 1. So I need a line here that does not have a slope of negative 1, or excuse me, that has a slope of negative 1, but does not have a y-intercept of 1. So we're looking for a slope of negative 1, but a y-intercept of anything but 1. So we're just going to start with answer choice A. And do a different color for each one. Answer choice A. We're going to subtract this 3 over. It's 3x. Now it becomes negative 3y equals negative 3x plus 3. We're going to divide everything by negative 3. We get y equals positive x minus 1. Well, that slope is different, so the answer is not A. That's out. All right, let's try blue for the next one. So again, same thing, just solving so that it's y equals mx plus b. So 3y equals negative 3x plus 3. We'll divide by 3. We get y equals negative x plus 1. Well, it has the same slope, but it also has the same y-intercept. So that's actually going to be infinite solutions. We don't want infinite solutions. So we keep on going. So we're going to subtract 2x, subtract 2x. So that's negative 2y equals negative 2x plus 2. Divide everything by negative 2. And we get y equals x minus 1. Nope. So hopefully the answer is D. Otherwise, we messed up somewhere, or I messed up somewhere. So we're going to subtract 2x, subtract 2x. So we end up getting 2y equals negative 2x plus 3. We'll divide everything by 2. Y equals negative x plus 3 over 2. And what do you notice? It has the same slope, but a different y-intercept. So cool, that means we did this problem correctly. So the answer is D. Now again, negative of this method. If the answer is D, it's quite a bit of work. But it fits with how I always talk about systems of equations and the number of solutions, because we always talk about the slope and the y-intercept. So by writing it to where we can see the slope and y-intercept, we can just follow those rules every time. So if you have some other way that you have been able to do consistently, you don't have to do it the way that I just said, but I really like this way. All right. Let's go through. It says for the given function g, what is the value of g of 8? So I always just remind people is what's usually in the parentheses, x. When all of a sudden 8 is in the parentheses, so that means we're just saying x is equal to 8. So now we're just going to plug that in. So it's 2 plus 8 over 8. So that's 10 over 8, which you could leave it as that, or we can simplify it and say it's 5 over 4. Both are acceptable. You could even put 1.25 if you wanted to. That's more work than I want to do, so yeah. All right, 17. Line H is defined by y equals negative 8x plus 7. What is the slope of a line that is perpendicular to line H in the xy plane? So perpendicular means that we have opposite sign. So the slope is the opposite reciprocal. Hopefully I spelled this word correct. I think I got it. So opposite reciprocal. So since the slope of the line they gave us was negative 8, the opposite sign is then going to be positive, and the reciprocal, we can think of negative 8 as being negative 8 over 1. So we're just going to flip that fraction. So positive 1/8. Boom. All right. So here, number 18, system of equations. It says the solution to this given system of equations is the ordered pair xy. What is the value of x? Well, since they want the x solution, we're going to eliminate the y. So again, I'm a big fan when both lines are written in standard form to do elimination. Could substitution work? Absolutely. Substitution work every time. But I think substitution usually takes longer. There's more steps and people make more mistakes. So that's why I really like elimination. But again, since they want x, we're going to eliminate y. So we're going to multiply both equations. So we're just saying what would make these y's the same. So we can make both the y's a 6. So we'll multiply the top one by 3 and the bottom one by 2. But we need one of them to be negative. I'm just going to make the top one negative because I see that the x's will actually be smaller at the top. So then it's negative 3x minus 6y equals negative 22. Nope. Negative 33. And then 6x plus 6y equals 48. So the y's eliminate. That was the whole point of us doing that. So negative 3x plus 6x is 3x. Negative 33 plus 48. Some people maybe want to switch it and say 48 minus 33. It's the same thing. That is 15. So we divide by 3, and we get x equals 5. Cool. So again, the reason why we eliminate the y and solve for x first is because I don't have to plug back in anymore. So a lot of times when we do substitution, we potentially solve for one of them, have to plug back in, and we make mistakes because we have to do more math. So yeah. All right. So then number 19. So number 19 is a very hard problem. Number 19 is probably up there for one of the hardest problems on any of these tests. So this question says rectangular prism A is similar to rectangular prism B. So the fact that they told us these two prisms, rectangular prisms, which they're just boxes, are similar means that they have the same angles, but then their sides are maybe proportional. So there is a factor that we multiply one rectangular prism by to get to the other. So some number. where the longest side of rectangular prism A corresponds to the longest side of rectangular prism B. Struggled reading that for a second. The table gives the volumes in cubic meters of 2 prisms. The length of the longest side of rectangular prism A is 6 meters. So what is the length in meters of the longest side of rectangular prism B? So how I've been kind of trying to explain this to people lately, or I did this the other day and I thought it worked. Maybe it doesn't. You guys can tell me if you think that this is good or bad. Is with proportionality like this. So this is how we kind of call this question. We consider it proportionality. Because these two shapes are proportional to each other. Their sides are proportional, and then also their volumes would be proportional. But the mistake that people think is, oh, whatever we multiply one prism by, we would multiply the other, one prism's dimensions by, we would multiply their volume by that to get the same thing. That's not how it works. So I kind of think is, we're going to think of it this way. So here, the volume of prism A, and I'm just going to use letters at first, is going to be equal to the volume of prism B multiplied by some factor. But it's not going to be multiplied by some just that factor. It's going to be that factor cubed. So I'm just calling it the word factor. We could have called it X. I've just been calling it the word factor. So again, the factor is what we're multiplying the dimensions of the shape by to get the other shape. So maybe we're doubling the sides in rectangular prism B to get to rectangular prism A, or maybe we're tripling them, something like that. But that does not mean that the volume itself is being doubled or tripled. It would be whatever that factor is, cubed is what the volume would be changing by. So here we can just plug in the numbers. So we know that volume of prism A is 96. The volume of prism B is 12. But we don't know what that factor is. We don't know what we're multiplying one prism's sides by to get to the other prism's sides. So we're just going to solve for the factor. So we divide both sides by 12. So we get 8 is equal to that factor. Ooh, that was bad handwriting. Cubed. So to solve for the factor, we're just going to do the cube root of both sides. So we get 2 is equal to that factor. So that means that we are taking prism B and multiplying each of its sides by 2 to get the sides of prism A. Well, since prism A has the longest side of 6, to get back to prism B, we're going to divide it by 2. So the longest side of rectangular prism B is going to be 3. Most of the time, though, they're going to give us the 3. They're going to give us that factor. And we just have to know that if it's volume, we're not just multiplying the volume by 3. It'd be by 3 cubed. It's that factor cubed. If it was area, it'd be that factor squared. Because area, I always say the unit for area is like inches squared, feet squared, meters squared. So it would be whatever that factor squared if they were talking about area. But if it was like perimeter or circumference, it's just that factor. Because how I always say, what's the unit for perimeter or circumference? It's just feet. It's just inches. So you're not having to deal with any exponent with that. So yeah, again, this is the hard version of this sort of question. All right, so number 20. So number 20, again, there are 2 ways to do it. I'm going to do it one way because I think it's the way that is more consistent. The second way, though, for this question is you could do completing the square. But I've been talking a lot more about doing the quadratic formula, so we're going to do it by using the quadratic formula. We'll talk about why I know that. So it says one solution to the given equation can be written as x equals 5 plus the square root of n, where n is a constant. Wherever you see the word constant, you can just cross it out, write number if you want. Because constant just means number. Don't worry about it too much for the test. So they want to know what is the value of n. So they want to know what number goes inside that square root. Well, the reason why I'd be thinking quadratic formula here or completing the square is because we usually try to find the solution to a quadratic first by factoring. But usually if we factor, the solution would just be like 5 or 7 or 2, not some radical thing. But when it's a quadratic where you see a radical, probably a good tell that we're going to do the quadratic formula. So remember the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you want to sing the song when you do it, you can sing the song. I do not want to sing the song. All right, so what I always tell people is let's write down what a, b, and c are. So just going up here, I'd say, okay, a is 1, b here is -10, c here is 14. Of course, I'm getting that because it's ax squared plus bx plus c. So then I'm just plugging into the equation below. So we get -b, so it's going to be -10 plus or minus the square root of -10 squared minus 4 times 1 times 14. And that is all over 2 times 1. All right, so now we're just going to do some arithmetic. So -10 is just 10 plus or minus the square root of 100. And then 4 times 14, or -4 times 14, if you need to, don't be afraid to do some of that math over to the side. So 4 times 4 is 6, carry the 1. So 4 times 1 is 5, or 4 plus 1 is 5, 56. This is minus 56 all over 2. So then that's just going to be 10 plus or minus. So 100 minus 56 is 44 all over 2. So this is where people usually get to, and then this is where we mess up, is simplifying the radical. So I actually do usually teach and think about doing prime factorization. So I just take that 44 and I just factor until it's only prime numbers. So that's what, 2 and 22. And that factors into 2 and 11. And since we're doing the square root, we're looking for groups of 2. So I would circle this group of 2. And then whatever number's left, so the 44 and 22 are gone already because we factored them. So this means we're going to have 10 plus or minus. The 2 can go on the outside, but the 11 has to stay inside. And the reason why that's helpful is because now we can simplify this fraction. Everything, both top and bottom, can be divisible by 2. So this 2, and then this 10 cancel each other out. So we end up getting 5 plus or minus the square root of 11. Now, if we look at the original equation, they only wanted the plus. So that just means if I write it down here, if I just get rid of this minus sign, it looks exactly like the answer. So n is not the square root of 11. N is the number inside the radical. So here n is 11. Cool. All right. So that's a no calculator. A lot of these problems on the no calculator potentially could show up on calculator. This sort of problem could. But yeah. All right. So you would normally get a break. I usually tell people during your break, like actually get up and walk around. So if this is your break, get up, walk around. Break up the boredom of sitting down doing math for an hour and a half. But I'm going to keep doing it because this is my type of boredom, I guess. All right. Again, I'm going to kind of skip. I don't really think usually people here in the beginning really struggle too much with these problems super early. So I'm just going to jump. I'm going to start with number 6, just because I think number 6 asks such a good question that I really want to emphasize to you guys because it's so crazy how many times we make a mistake with this question. So yeah, so number 6 says the function f is defined by f of x equals 2x minus 4. What is the y-intercept of the graph of y equals f of x in the xy plane? So remember, y-intercept means that we are going to make x equal to 0. So we're literally going to rewrite the equation, but wherever we see x, we're going to put 0. So it's 2 times 0 minus 4. What's 2 times 0? That's 0. So that just goes away. So we get -4. Now, of course, some people are like, Hampton, that was so easy. That's just y equals mx plus b. It's the number at the end. Yes. But for the problems that aren't as simple, we make mistakes and we still try to do that. Look at the number at the end. That does not work all the time. So I just now tell people, plug in 0 for x. If it's calculator, you can literally type that into your calculator. All right. So number 7 says the table summarizes the number of public schools in 2 California counties in 2017. A public middle school will be selected at random from the 2 counties. So we know we're picking a public middle school. So elementary schools are not being picked. High schools are not being picked. So those are gone. And then the totals aren't being picked. We're only talking about middle schools. All right. What is the probability, to the nearest 100th of selecting a school in San Diego County? So we are wanting to pick a school in San Diego County, but we know we're picking a middle school. So there's 587 middle schools to pick from. How many of those are in San Diego? 165. And then I honestly don't know what the answer is. I don't have a calculator. Let me type that in. 165 divided by 587. I should have thought about bringing 0.28. Cool. Because that would just be calculated at that point. All right. So again, with these problems, the biggest thing is getting the number on the bottom. Once we get the number on the bottom, not too bad. All right, number 8. A museum built a scale model of the solar system throughout its city where 1 mile in the model represents an actual distance of 400 million miles. The model of the sun is X miles away from the model of Earth. Which expression represents the actual distance in miles between the Earth and the sun? So a lot of times when they're saying like a scale model or a scale drawing or something like that, we're probably going to be able to do a ratio. So here they said that basically by the scale, that's the ratio. So 1 mile in the city, or in the model, excuse me, over 400 million. So it was scale over, or it was model over actual. Well, they said the model of the sun is X miles away. So they said, what would represent the actual? So we don't know the actual. So we'll call Y the actual. So we cross multiply. So that's why I like writing this. So we get Y equals just that 4 million X. Now, again, this is a problem where like some people are like, well, I could have said that instantly. Yeah, but writing it out, it just means we maybe are going to make fewer mistakes. Because for a lot of us, we know how to do a lot of this stuff. It's just we make silly, dumb mistakes. And then it just kind of stinks because we get our score and we're like, wait a second. I definitely knew how to do a lot of these problems. All right, number 9. The list shown gives the heights in inches for the 6 10-year-old children in a group. 52, 53, 54, 54, 55, 56. A 7th child with a height of 60 inches will be added to the group. Which of the following correctly describes how the mean and the median of the group will change when the 7th child is added? All right, we're going to be able to do this problem without doing a single step. I'll say the steps that we could do, meaning do the actual math, but we can actually say the answer without really doing any work just by knowing stuff. So the quick way of doing this problem is if you ever have a problem where they're talking about median and they're just taking a set of data and including one more number or taking a number away. It's like this problem. We have the data right now, and then they're going to include somebody who is 60 inches tall. The median will pretty much never change. I'm just going to say it won't change. That is a general statement. Technically, I could be wrong, but every time that's happened, the median has never changed when this sort of scenario happens, where they include a new number or get rid of a number. So I already know A and B are out. And then here, the reason why I don't have to actually calculate the mean is because we're including 60. 60 is larger than all the other data we have. So if we are including a number that is larger than the rest of our data, our mean is going to go up. Always. How I always kind of think about it is if you're in school and your grade in a class is an 85 and on the next test you get a 100, your grade is going to go up because 100 is greater than the 85 score that you have in your class. If the number we included was less than all our data, so if it was less than everything, then your mean is definitely going to go down. So if, let's just say they added a student who was 44 inches tall in this problem, the median would still remain the same. So instead of adding 60, we are adding 44. So the median will still stay the same. But now the mean will decrease because we included a person that is much less than all the others. So basically, if you're including an outlier, your mean will change in whatever direction that outlier is in relation to the rest of the data. So if it's much bigger, then your mean's going to go up. If you're including something that's lower, then the mean will go down. But the median will remain the same. The median will remain the same or remain constant. I shouldn't say constant. It'll remain the same if we include one number or if we got rid of it. Sometimes I'll say, hey, we're going to get rid of this number. The median will remain the same. Now, if you wanted to do this the math way, the median, I usually for something this small would just do the cross-out method. So just literally small, big, small, big. If you have 2 left in the middle, you're going to do the average of them. Now here, the two are the same numbers, so the average of 54 and 54 is 54. We're done. And then just do the median again, but add 60. So do the cross-out math method with those. So I'd say small, big, small, big, small, big. Oh, the median is 54 again. So that's why it is. And then the mean, you can just add them up and then divide by however many you have. So 52 plus 53 plus 54 plus 54 plus 55 plus 56 divided by 6. Write that number down and then add them all up again, but include the number 60 and then divide by 7 because now there's 7 numbers. Yeah. All right. So number 10. I'm not going to read all this stuff. Normally, I would say to read it, but I don't want to. So it says 10. The line of best fit underestimates one student's reported average time spent using the internet on Saturdays by more than 2 hours. For how many hours did the student report reading offline? So they said that it underestimated. The line underestimates. That means the line is under a point by more than 2 hours. So let's go up. We'll look at this. I can't get it all into one little frame. But we're saying that the line is under a point by more than 2 hours when it comes to using the internet. So I would notice that point all the way up there. Now, we have to realize that the y-axis is by half hours. So if I look, that's like half an hour, 1 hour, hour and a half, 2 hours. So it is a little bit more than 2 hours. But the question didn't want to know how much time did they spend using the internet. The question wants to know how many hours did the student report reading offline. So they're asking for the X value of that point. So we go down to 1.5. So this person spent 1.5 hours reading offline. Cool. So the big thing with that problem is make sure we're looking at the right axis. Very often people look at the wrong axis. They want to put the 5. But that is the amount of time that they spent using the internet. So yeah. All right, number 11. It says, according to the line of best fit, if a student spends an average of 1.25 hours reading offline on Saturdays, which of the following is the best estimate of time the student would be expected to spend using the internet on Saturdays? So we're talking about somebody who spent an hour, 1.25 hours using reading offline. So I would go to that x-axis. 1.25 is going to be halfway between 1 and 1.5. So I'm just drawing up until we get to that line, because they're saying according to this line of best fit, or based on the line of best fit, how much would we expect them to use the internet? So just where it intersects, that looks like it's between 2.5 and 3. So that person spends between 2.5 and 3 hours on the internet. All right. All right, so question 12. Line K is defined by y equals negative x plus 5. Line J is parallel. So parallel, we saw perpendicular earlier. Parallel means that they have the same slope. So we have the line y equals negative x plus 5. Line J is parallel to line K on the xy plane. What is the slope of line J? Well, parallel lines have the same slope. So we just say the slope of the line they gave us was the number in front of x. We have to imagine there's a 1 there, so it's -1. So it's the same. Cool. Those are the types of problems where we can kind of save some of our time because there really isn't any work to do. It's just knowing definitions. All right, so number 13. For a survey, students were assigned to either group R or group V. Combined, the students in both groups answered a total of 17 questions. Of these, a total of 9 questions were answered by the students in group V. The equation 4R plus 9 equals 17 describes this situation where R represents the number of questions answered by each student in group R. Which of the following is the best interpretation of 4R in this context? So I usually try to think about this question as units. So I would notice that 17 was the total number of questions that were answered by all groups, both groups. This 9 was the total number of questions answered by group V. So that means each of these groups of each of these terms that we have here. So I'm going to highlight them instead of that. So the 17 represents a total number of questions, but it's for both groups. The 9 represents the total number of questions, but for group V, because they told us that group V had 9. So the 4R also must represent a total number of questions. And since it has R in it, the logical thing would probably be to say, oh, that's the total number of questions that group R would answer. And if we look at the choices, C says the total number of questions answered by students in group R. Boom. So thinking about units with those. All right, so number 14. How many solutions does the equation 5 times x plus 1 equal 5x plus 5 have? So I always say with this question is we want to get them to, so that way things kind of look more the same. So we're usually going to want to FOIL this stuff or distribute, combine like terms, that sort of thing. So this left side, I'm going to distribute the 5. So we get 5x plus 5 equals 5x plus 5. Well, the left side and right side are exactly the same thing. So if they're exactly the same thing, always going to be infinitely many solutions. If we wanted to think of both sides as being a line, so I could basically say that this left side is a line and this right side is a line. And the reason why is they're both written as mx plus b. So I could think of it as, oh, these two lines have the same slope and same y-intercept. A lot of people don't love looking at this and saying that both sides is a line. Both sides are a line. But I think I like it just because it fits that the way we think about the number of solutions, especially when we can see that they can be thought of as linear expressions. Yeah, you could also just say they look exactly the same. So if they are the same thing, they're going to intersect infinitely many times. All right, so number 15. It says the table shows the results of a survey on the average amount of money, D in dollars, consumers would be willing to spend on a product and their corresponding age, A, in years. Which equation could represent this linear relationship? So I'm actually going to do this the quote long way. So I always just say if you're ever trying to find the equation of the line, we want two things. We want the slope and we want a point. So slope and a point, slope and point, slope and point. Because as long as we have the slope and a point, we can use point slope form to find the equation. So here they're asking for this equation. So I'm going to say, hey, I want the slope and a point. And what we have to realize is that this table of values is basically just a bunch of points. Because if we have a bunch of points, we can find the slope by using our little y2 minus y1 over x2 minus x1. And to be honest, actually, most of the time in these graphs, the x value will be the left column. The y value or f of x value will be the right-hand column. I don't know if they purposely do that, but it is something that I've noticed. All right. So then we just label these points. So these are corresponding points. So x1, y1, x2, y2. You could have used any 2 points. I just picked those because they were the first 2. So now I just go down here and I just plug it in. So it's, y2 is 36 minus y1 I said was 42 over x2 I said was 28 minus x1 which was 25. And then you could use your calculator if you wanted to, if you don't feel confident doing this by hand. So -6 over 3, which simplifies to -2. So our slope is -2. Now, if we noticed all these answers, they are written as our y equals mx plus b. Only one answer has a slope of -2, so I could stop and just say the answer is A. I'm going to go ahead and do it the long way, though. I'm just going to pretend like, hey, let's just say 2 answers had the slope of -2 or something. So what would I do next? I would now use point slope form. So point slope form, y minus y1 equals m. That was a terrible m. X minus x1. So it's y minus 42 equals -2 times x minus x1, which was 25. And now we're just distributing combined like terms, that sort of stuff. So I'm going to do the right side. So it's -2x plus 50. So we'll add 42 over to get this written as y equals mx plus b. We get y equals negative 2x plus 92. Cool. And that was A. So again, very often we're going to have to find the equation of line. So you are likely to do this on basically every test. So if you're taking a test tomorrow, you'll have it. If you're taking the test again in June, you'll probably have it. Most SATs have this sort of question. So anytime you're trying to find the equation of line, it is usually helpful to think, hey, let me figure out the slope and have a point, because then you can use point slope form. So I personally don't ever really plug directly into y equals mx plus b. All right. So number 16. So if x is the solution to the given equation, what is the value of x plus 1? So there are two ways that we could do this problem. I'm going to do it the longer way because that is the way that most of us tend to do this question. And that is, we're just going to solve for x. So depending on what calculator you have, so if you have the TI Nspire, don't forget you can use nsolve, or if you have the TI Nspire CAS, you could use solve. But if you don't have that calculator that can do that, then we can just do it by hand. So we're going to distribute and combine like terms. So we'll do the left side first. So that's just 4x plus 4 equals 6. And then we'll distribute the 2 on the right side. So 2x plus 2. I would actually probably recommend drawing those little lines. That way you're telling yourself to distribute. So I know I didn't do that until after I just distributed, but yeah. And then we're just going to solve for x. So I'm going to move this 2x over. So then we get 2x plus 4 equals 8, because I'm doing 6 plus 2. And then we're going to get this x by itself, so we'll subtract 4. So we get 2x equals 2. So we get equals 4, excuse me. Should just erase that, huh? So then divide both sides by 2. So we get x equals 2. Thankfully, they did not put 2 as an answer. A lot of us for this sort of question just forget what we're solving for, and we say, oh, x is equal to 2, so I'm going to put 2 as the answer. But again, this problem didn't want to know what x is. It wants to know what is the value of x plus 1. So we're going to have to take this x and just plug it back in. So it's just 2 plus 1, so we get 3. All right. I'm going to show you the short way as well, because honestly, I would not do it the way that I just showed you right there. So how I would do this is I would realize, oh, I can just get x plus 1 by itself. I'm going to move this 2x plus 1 to the left side. So now the left side has become 2 times x plus 1. But again, what does the question want to know? It wants to know what is the value of x plus 1. So I just need to get x plus 1 by itself. So I'm going to divide both sides by 2. X plus 1 equals 3. So I don't have to worry about doing all the distributing and all that sort of stuff. But the reason why I did it the first way is because that's how most of us see to do it. This way that I just did it, I would say is more advanced. Now, it was way less work, but I just don't think a lot of us see to do it that way. So I did this more for maybe students who have quite a high math score. Maybe this is a way that you could approach this question to where you don't make that mistake of accidentally putting the value of x, because they very often will put the value of x as an answer knowing that we will make that mistake. So, yeah. All right. So, number 17. The initial number of bacteria in a population is 10,000. The bacteria in the population are observed to double in number every 12 hours. So, every 12 hours, it's multiplying by 2. So, which graph represents the number of bacteria y in thousands, x hours after the initial observation? So for this, I would almost just kind of guess and check. We know that we have 10,000. So when it's been 0 hours, I'm still going to have 10,000. And then when it's been 12 hours, so I would almost just basically take points. So when x is equal to 12, my y would just be 10,000 times 2. So 20,000. When x is equal to 24, that's another 12 hours. I would multiply by 2 again. So that means y is now 40. And so on and so forth. If I need to, I'll do more points. So again, I'm basically just picking points and guessing and checking. I know that those points should work. So we'll see. So the issue is 12 doesn't really show up on the graph, so it's a little bit harder to see. So we'll try the 24. So 24, when x is 24, y should be 40. So we'll just look at answer choice A. When x is 24, y does look like right there, it'd be 40. Okay, that could work. When x is 24 here, that is not at 40, so B is out. When x is 24, that is not at 40, so that is out. When x is 24, yeah, that's not it. So the answer is A. So again, it's another problem where I'm just kind of picking points and plugging in and guessing and checking. So again, a lot of problems where they're asking what's the graph of some scenario. Very often I'm just picking numbers and guessing and checking. All right. So number 18. Box plots. So there are two things we need to know with box plots. And then we'll actually read this question. One is range and one is median. So I'm just going to very quickly teach median. The median's super easy. The median is just the line in the box. So that'd be the median. That right there would be the median. That one would be the median. So all of those are the medians of their respective data sets. All right. And then this problem is not dealing with the median, though. It's dealing with the range. So we'll read the question. It says the box plots shown summarize the data in each of 4 data sets. Which of the 4 data sets has a range of 6? So remember, range is the maximum minus the minimum, or the largest value minus the smallest value. And in box plots, we basically ignore the box, actually, even though it's called a box plot. The only reason we care about the box is just because with the median, you look at the line inside of that box. But when you're actually calculating the range or anything like that, we actually don't use the box. The first line is the minimum, or the smallest value. And the last line is the maximum here. So we're just going to have to look at the min and max of each of these data sets and just subtract them and figure out which of these has a range of 6. So for this one, if I kind of look down, it looks like it's about at 6, but the minimum is at 2. So this would be 6 and 2. So if I subtract those, 6 minus 2 is 4. So the answer is not A. This looks like it's at 3. This looks like it is at 13. So 13 minus 3 is 10. Nope, that is not 6. This looks like it's at 1. This is at 14. So 14 minus 1 is 13. So clearly not that. So the answer should be D. So this is 9 and 3. So 9 minus 3 is 6. Cool. So median and range are the two things they ask us about when it comes to box plot. All right. So 19. It says a forest contains different species of trees. Let T represent the total number of trees in the forest. Let H represent the number of hickory trees, and let K represent the number of oak trees. If a tree is selected at random from the forest, which expression represents the probability of selecting a tree that is neither hickory nor oak? So we want any tree as long as it's not an oak or a hickory tree. So the issue with this problem that a lot of times we mess up with is we only think that the forest has hickory and oak trees. Nope. They could have many different trees. Maybe some reason has palm trees or elm trees or some other tree that I don't know names of trees. So sometimes how we find the probability of something occurring is not by knowing actually how often it occurs. It's by knowing how often the other things occur. So here, probability, we usually put the total on the bottom. Depending on the problem, again, we had one earlier where we didn't put the total of everything on the bottom. But here we're putting all the trees. We're choosing from all the trees. So of all of these trees, we want to know what's the probability that it won't be hickory or oak. So we're just going to be able to say, all right, well, we'd be happy picking any total tree except for hickory. So that means we're going to take away the hickory tree. So I'm going to take away H, so subtract. But I also don't care about oak, so I'm going to take away oak. And again, in math, how do we take things away? We subtract. So the probability of picking a tree that isn't hickory or oak is T minus H minus K all over T. So the answer is B. If you wanted to, you could also just pick numbers for T, H, and K. So you could just say, hey, there's 10 trees. There's 3 oak and 1 hickory. And then you would know, like, okay, so I said 3 oak, 1 hickory. So that means there's 4 of those. So there's 6 trees that I'd be happy with out of those 10 trees. So it should be 6 over 10. And then just plug in for H, K, and T into all the answers until you get 6 over 10. I don't love that way, but it does work. All right. It's number 20. In the xy plane shown, the quadrants are labeled 1, 2, 3, and 4. The graph of y equals negative x plus h squared plus k, where h and k are positive constants, again, we can say positive numbers, is a parabola. In which quadrant is the vertex of this parabola? So what we have to recognize is that the parabola they just gave us is written in vertex form. So remember vertex form, the number inside the parentheses with the x is the x coordinate of the vertex, but it's the opposite sign. So this is saying it's going to be at negative h. And then the number on the outside that we add or subtract, we keep that sign, and that's going to be the y coordinate of the vertex. So this vertex is going to be at negative h, comma k. So h and k are positive constants, so since it's negative h, that means we're moving to the left, h, and we're going to move up, k. So this vertex is going to have to be something right here. So it's going to be in quadrant 2. The only thing that the negative sign does in front for us is it just tells us this parabola would open down. That's what the negative sign does in front. It's not going to change the sign inside those parentheses. It just means we have a parabola that's opening downwards. All right. All right, so number 21. At the beginning of the day, there were 500 items for sale in a store. The number of items for sale at the end of the day was R% less than the number at the beginning of the day. Which expression represents the number of items for sale at the end of the day? So I would notice that they mention a percent change because they said percent less. So that means we're going to think of our percent change equation. However, this is the one problem that's just a little bit unique compared to most of the other problems that we deal with percent change. And that is we're not going to use the percent change equation we did earlier. We're going to use a modified version of it. It actually is the same equation, but it just is a little different at the same time. So the equation we're going to think of is it's still the initial value. But instead of saying 1, we're going to say 100. So it's going to be 100 plus or minus the percentage still as a percentage all over 100. So in this form, we're not going to turn the percent into a decimal. We're going to leave it as the percent. So if it was 22%, we would plug in 22 into this equation, not 0.22 like we did with the problem earlier. So here they told us that we started with 500 items. So that is our initial value. And they told us that it's R% less. So since it's less, that means we're going to subtract. And notice how R is it actually is a number in front of the percent sign. So that would be the percentage. So we're going to say 100 minus R all over 100. And then if we remember multiplication, it doesn't matter if we say 500 times the parentheses or if we have the parentheses times 500. The order doesn't matter. The answer is B. So yeah, again, this problem is just tough just because of how they write it. This is the only problem as far as I'm aware where they actually express it in this way. So that's why I personally like the other equation we did earlier where we already converted the percentage to a decimal. All right, so in 22. The area in square inches of a certain right triangle is given by the equation A equals 1/2 B times 2B, where B is the length in inches of one of the legs of the triangle. Which expression represents the length in inches of the shortest leg of the triangle? Well, let's just review. What is the area of a triangle? We usually say that the area of a triangle is just 1/2 base times height. So 1/2 BH. Well, they told us for this problem that the area of this triangle was 1/2 B times 2B. Well, if we just look, what do these two equations have in common? They both have the 1/2. So those kind of like cancel each other out. They both have that. Because a lot of people look at that. So again, they want the shorter leg. Well, I would just notice since 2B is written where we usually write H, we could probably say that H is equal to 2B. and that what I'm calling the base is equal to what they're calling B. So which of these is shorter? B or 2B? B is shorter. Again, it looks weird because I said maybe I should write this as base times height. And then this B here is the base. I'll write it that way. Cool. All right. Number 23. Scientists took 94 ice core sections from a glacier. Each section was in the shape of a right circular cylinder and had a length of 1 meter and a diameter of 0.1 meter. Which of the following is closest to the total volume in cubic meters of the 94 sections? So we're taking 94 little cylinder cutouts from this glacier. So they want to know what's the volume of all 94. So we could just say, hey, let's find the volume of one of those core cutouts, and then we'll just multiply by 94. So if we need to, we can go back to the beginning of the test, or the beginning of the section, because they do give you the volume of a cone, or of a cylinder, excuse me. So the volume of a cylinder is just pi r squared h. Okay, so we're going to try to find the volume of one of these cylinders. Remember, r is the radius, h is the height. So the volume is going to be pi. That doesn't change. So they didn't tell us the radius, but they did tell us the diameter. So the diameter, keep it in my mic. So the diameter is 0.1. So that means the radius is going to be half of that 0.1. So we type that in our calculator and we get 0.05. That's going to be squared. And then times the height. Now, this is where there's nothing that says height, but they do say length. The reason why I think they say length is because when they're cutting out core sections, I think they're cutting them sideways, so it's kind of looking at it like a log. So I could almost just like rotate this to where now, I'll rotate that way. Now it looks better this way. Rotate that way to where now that length became a height. So their length is really our height. So that's just going to be 1. And so that's going to be the volume of each of our cylinders. But again, that's one cylinder. How many cylinders are they doing? They're taking 94 of these. So we're going to take that number, and we're going to do 94 times that volume that we just solved, which I don't know what it is, and I don't have the calculator. And so we type that in our calculator, and we get 0.7. And it's going to be close to 0.7. Notice how they say which of the following is closest. So that means we're probably not going to get an exact number. So if you ever see them say which of the following is closest, or if you see them say approximately, that means that you're probably going to have to maybe round at the end. You're not going to get an exact number. All right. So cylinders. Okay. So 24, in the figure shown, GE and DH, line segments GE and DH, intersect at point F. Which of the following additional statements is or are sufficient to prove that triangle DEF is similar to triangle HGF? So you remember earlier, I said when triangles are similar, we don't really care about the sides. We care about the angles. The angles have to be the same. So here are the two things we have to use to determine if this is sufficient to say that they are similar triangles. Is to either say that the length of line segment DE is 1/3 of the length of line segment HG, or Roman numeral 2, which is that DE is parallel to HG. Okay, so we're going to have to review a little bit of stuff that we usually do in geometry, everybody's favorite class. So right now we can say that without even them, the 1 or the 2, we can say that angle F here and angle F here are the same. Those are called vertical angles. Anytime you draw two lines that intersect, the angles opposite each other will always be the same. No matter what two lines you draw, the angles that are opposite each other will be the same. Always. Oops, that did not erase. So we know that. And again, to say that triangles are similar, we need to say that at least two angles are the same. If you remember our proofs, it's the angle-angle theorem. identity. I don't know what it's called. It's angle something. All right. So again, I don't really care about the lengths. So 1 is never going to be correct. The only time you're going to worry about the lengths is if you're thinking of whether triangles are congruent. If you're talking similar, probably do not care at all about the lengths of sides. So then now we have to decide, okay, is saying that this DE is parallel to GH, is that enough? So if you remember with lines, that if we have two lines that are parallel and then we draw a transversal is a line that crosses those. So I'm going to kind of draw some lines here. They're not going to be exact matches, but they'll line up close enough. So I'm just extending DE. I'm extending DE, GH, and EFG. So we have those two lines that are parallel that I have marked with those little arrows, which we use to indicate that they are parallel. When we have a line that crosses through both of them, like GE is doing for us right there, then we create those angles that can be considered either alternate interior or alternate exterior. So yeah, so here I could say that this angle here will be congruent to this angle over here because those are alternate interior angles. So by knowing that these two lines are parallel, DE and GH, and having EG pass through those two parallel lines, we can now say, because of alternate interior angles, that those two angles are the same. So now we have said that there are two pairs of equal angles in these two triangles. So because of that angle-angle similarity theorem, Roman numeral 2 is sufficient to say it. So 2 is sufficient, but 1 is not. I could have also even said that it will be, because even DH, line segment DH, so if I move this so it crosses a little bit better, even that's also going to create some alternate interior angles. So now I actually showed that all three angles are exactly the same because of knowing some of our geometry rules from way back in the day. So yeah. So again, similar triangles means that the angles are the same. The sides will be proportional, but usually with similar triangles like that question, you can ignore the fact that sides will be similar to each other. But congruent triangles is where we really think about the sides and the angles. So congruent triangles have to be same sides and angles. Similar is just same angles. All right. So 25 says the scatter plot shows the relationship between two variables, x and y. A line of best fit for the data is also shown. So the question says, which data point has an actual y value that is 2 more than the y value predicted by the line of best fit for the corresponding x value? So they're saying that the actual value should be 2 more than that predicted by the line. So we're looking for a dot that is 2 more than the line. But one thing we have to be careful of. So anytime you see a graph like this, pay attention to the intervals, because a lot of people want to go to this point because that is 2 little ticks above the line. However, if we go look at that y-axis, these little tick marks aren't by 1s, they're by 2s. So actually, that point that I'm talking about right there is 4 more. Again, we only want to be 2 more. So we're going to have to see. So we can even use the answer. So they said 210. Well, no, 210 is right here. That is not. So 320. Well, we just did that point. That's 4 more. 418. Well, 418 is below the line. So hopefully the answer is D. So 530. So that is this point. And if we look, that is 1 little tick mark above. So that means it is 2 more. The answer is D. So again, even though this question is number 25, and yes, the math does get more difficult as you go through it, it doesn't mean that every problem at 25, 28 is going to be some super complicated thing. So again, don't overthink some of these things. So yes, sometimes they will be that easy. All right, 26. A plant's height is 1.25 times its height from last week. What was the percentage increase in the plant's height from last week? So we can kind of think of this way. We're going to say that the height now is 1.25 times the height last week. So our new height is that equation I have right there. So the reason why I like seeing it this way is because they're talking about percentage increase. Remember, the equation we think of with percent increase is the initial value times 1 plus or minus the percentage as a decimal, R. Well, this is where we get the 1.25 from. That's how we usually get those numbers. So I'm just going to say that the 1, and if you're ever trying to solve for the percent change, just do plus. So 1 plus R is going to be that 1.25. So we're just solving for R. So we're going to subtract 1. So we get R is equal to 0.25. But remember, R is the percentage as the decimal. It's the decimal value, not an actual percent. So we want to figure out the actual percent. So to convert a decimal to a percentage, you multiply again by 100. So we get 25%. So the answer is D. So this test was very percentage heavy. A lot of tests lately have been. So you're probably going to be doing some percent change stuff for sure on every test. And we actually have another percent problem coming up in just a moment. All right, so 27. In a forest, white pine trees between 15 and 45 years old grow 36 to 48 inches in height each year. A 15-year-old white pine tree growing in the forest was 240 inches tall. Which of the following inequalities gives all possible values for the tree's height h in inches at the end of its 45th year? All right. So they said a 15-year-old white pine tree growing in the forest was 214 inches tall. So at 15, which is when they had started, it was 15, it was already 240 inches tall. So that means that height was 240. But so a lot of people want to say, oh, the answer is C here. But no. It's going to either grow by 36 inches per year. So 240 plus 36 times however many years. We'll say X years. Or it could get so that's the smallest it's going to be. So this is the minimum. We'll say the minimum is going to be the 240 plus the 36 times however many years. And then the maximum height that it is going to be, spelling max with an S, is going to be that 240, but growing its maximum each year, which was 48 inches. And so they want to know what could have been at the 45th year. So we're going to say, how many years did it grow? It grew from 15 years old to 45 years old, it grew for 30 years. So now we're just going to plug that into our calculator. So this is going to be 240 plus 36 times 30. And 240, oops, I don't need that parentheses. 240 plus 48 times 30. And we end up getting the minimum height is going to be 1320. And the maximum height is going to be 1680. So the height could be anywhere between there, because it's not like it's necessarily going to have to grow its maximum amount each year. So maybe one year it grows 36 inches, the next year it grows 40, then it grows 36 again, then it's 45. So it can grow any amount, but it's going to at least grow that 36 per year. So it's going to at least be 1,320 inches tall. Or at most, it could grow 48 inches a year. So at most, it could be 1,680 inches tall. So the answer is D. All right, 28. So here's where we're dealing with a different type of percentage question. Zoom in so it doesn't have. Okay. P% of X is 3. Which expression represents X in terms of P? So if you ever see them say the word is and of with a percentage, so there's no percent change problem here. They didn't say percent increase, percent decrease, growth, decay, anything like that. That means we're going to do the equation is over of equals the percentage over 100. And again, I actually write this when I do this problem, so you guys should be writing it too. And then we just have to put things in the right spot. So they said P%. Well, percentage is always the easiest. So P is the percentage. So we have the right side of that equation. Of X is 3. So they said of X. So X is the of, is 3. So 3 is the is. And then we're just going to cross multiply. So when you have a fraction equal to another fraction, we usually cross multiply. So we say 3 times 100. I'm going to actually leave it as 3 times 100 because if you look at the answers, they actually didn't multiply them. Why did they not do that? I honestly don't know. They just sometimes do random stuff. And that equals xp. And then this question says, which expression represents x in terms of p? So what I always say is whatever they say before the in terms of. So here the x. That's what you're getting by itself. Whatever they say before in terms of is what you're getting by itself. So we're going to get x by itself. So we're going to divide both sides by p. So now we just have 3 over 100 over p equals x. So the answer is C. So this is number 28. They will classify this type of question as a hard question. It is hard if you don't know percentages at all. But if you know this little is over L equals percent over 100, it's basically the same thing every single time. So yeah. All right. Number 29. Says, which of the following equivalent forms of the given function f displays as the base of the coefficient the y-coordinate of the y-intercept of the graph of y equals f of x in the xy plane? So here for this problem, they are saying that they want to display, so display means show, the y-coordinate of the y-intercept of the graph. Well, if you remember, we said whenever they're talking about y-intercept, that means we're saying that x is going to be 0. So they want to see the y-coordinate of the y-intercept to be displayed in the graph, in the equation. So let's just find out what the y-intercept is. So we're just going to plug in 0 for x wherever we see x. So our function now is going to be f of 0 is 3 times -2, or 3 to the power -2 times 0 plus 1. So that just turns into 3 to -2 times 1, so just -2, which you could use your calculator, or you can know that if we have a negative exponent, we can move it to the bottom. So then 1 over 3 squared is 1 over 9. So they're telling us that 1 over 9 is the y-intercept, or we determined that. But they're telling us that they want to see that y-intercept. They want it to be displayed in the equation. So they want us to see it in the equation. So I would just say, which answer shows us 1/9 in the equation? B, it's right there. No other answer shows us 1/9. So again, they're asking for the y-intercept. They just said that they wanted to see the y-intercept. So we wrote the equation, or we figured out what the y-intercept is and just saw which one had that point in. All right, so number 30. It says 2 different store owners in a shopping center estimated the percentage of all visitors who wear eyeglasses. They each selected a random sample of the shopping center visitors and recorded whether the visitors were wearing eyeglasses. The results from each sample are shown in the table below. So it says, if the associated margin of error was calculated the same way for both samples, which of the following is the most likely reason that the result for sample A has a larger margin of error? All right, so margin of error is basically just how wrong we would expect to be. That's kind of as simple as I can put it. Margin of error is just how wrong would you expect to be when it comes to applying data that you collected from a sample and generalized it to a population. So the way we do this is sample size does affect the margin of error. And how it affects it is the bigger your sample is, the smaller your margin of error. And how I kind of just try to explain it is, think about it is, if my sample gets bigger, I'm getting closer to asking everybody that I'm curious about. So the bigger and bigger the sample I get, the closer and closer I get to asking everybody about this. So as I ask more people, because I get closer to asking everybody, I'm going to feel more confident in my data. So my amount of error that I'm expecting would go down. So as your sample gets bigger, your margin of error will get smaller. So here, they're just saying which of these statements is true. So we'll just go through the answer. So A, sample A included more visitors than sample B. Well, if we look at these margins of error, sample B had the smaller margin. So since sample B had the smaller margin, that means that it had to have a larger sample. It had to include more data. So that's why A, not correct. A would be saying that it has more data, so its sample would be bigger, which means its margin of error would be smaller. So then B, sample B included more visitors than sample A. Yeah, we could say that because we know sample B had a smaller margin of error. So the smaller the margin of error, the bigger the sample gets. All right. So now going through these gridded in. And just because they're gridded in does not mean that they're necessarily much more challenging. Again, on the no calculator even, most of those gridded in questions were actually not too complicated. There were a couple that were a little bit harder, but not all of them are going to be something that's very challenging. So it's the same thing with these gridded ins on the calculator section. So don't overthink them, basically. All right, so 31 says a limestone stalactite grew in length at a rate of 1/8 of a millimeter per year. At this rate, how many years would it take for this stalactite to grow a total of 4 millimeters? So very often with rates, the word rate comes from ratio. I oftentimes do a ratio. So they said it was 1/8 of a millimeter per year. So 1/8 millimeter per 1 year. Now I'm just writing the units so we can see it. And they said at this rate, how many years would it take for this stalactite to grow a total of 4 millimeters? So we know that it's supposed to grow 4 millimeters. So they want to know how many years. So we can cross multiply. So we get 1/8 x equals 4. So to solve for x, we can multiply both sides by 8 to get the x by itself because that cancels on that side. So we get x equals 32. All right, so now number 32. It's another system of equations. They're asking what is the value of 2x. Again, we're trying to think what is x. So we're going to eliminate y. Now, what we can realize here is that the y's are already the same number. It's just one of them is positive and one of them is negative. So we can just go ahead and combine like terms here. I'm just going to go ahead and combine them. So x plus x is 2x. The y's eliminate. And then 10 plus 4 is 14. And again, look what the question's asking for. They want to know what is the value of 2x. Well, we just saw right here that 2x is 14. So our answer is just 14. So again, these problems are not always super complicated. All right, so 33. If 3 square root of x minus 3 plus 10 equals 22, what is the value of x minus 3? So again, we could treat this problem as let's just try to solve for x. So where you want to get the x inside the radical, so we want to get that radical by itself. So we'll subtract the 10 first. So 3 square root x minus 3 equals 12. So let's get the radical by itself. So we'll divide both sides by 3 to get that radical by itself. So square root of x minus 3 equals 4. So to get rid of that square root, we'll just square both sides. So now we get x minus 3 equals 16. And in fact, I would stop. I don't actually have to solve for x because they didn't want the value of x. They want to know the value of x minus 3. So x minus 3 was 16. If you were to solve for x, that'd be fine. You would get x equals 19. You would just have to pay attention and make sure we answer the right question and then do 19 minus 3, and it would get you back to 16. All right, so number 34. The table gives the average speed s in miles per hour of each lap around the track for one racing team. For how many laps was the average speed greater than or equal to 150 miles per hour? So they're saying how many was it greater than, for how many laps was it greater than 150 miles per hour or equal to it? So I would look and I would notice, okay, 0 to 140, nope. 140, 145, nope. 145 to 150, nope. 150, 155. Yeah, that's good. 155 to 160, yes, that's still bigger than 150. And then 160, 165, yeah. So these three are good. So we just have to add these three numbers. And when we add those, 57 plus 52 plus 35, I believe we get 144. So again, they said greater than or equal to 150. Value speeds between 155 and 160 are still greater than 150. Values between 160 and 165 still greater than 150. All right, so again, problem is not too bad. All right, so number 35. So this one takes a little bit of work. Me not having a calculator, it's going to be a little bit annoying to do, but it says Aditi and Bella each attempted the long jump 5 times during a track meet, and their distances are shown in the table. The mean distance for Bella's attempt was 0.3 meters greater than the mean distance for Aditi's attempts. What is the value of X? Well, let's find the mean of Aditi's, because then whatever Aditi is, we will add 0.3, and that will give us Bella's mean. And then we can find what that one jump that we're missing is that would allow Bella to have that mean jump distance. So to do mean, so Aditi's mean is going to be 4.2 plus 3.8 plus 3.2 plus 4.0 plus 4.3 all over 5. And I believe, if my math is correct, that this gives us 3.9. Let's see, 8, 12, 16.3, 19.5. Yeah. So 3.9. So we're now going to add 0.3. So we get 4.2 because that means that Bella's mean is 4.2. So here we know Bella's mean is 4.2. And we would get that by doing X plus 4.4 plus 3.7 plus 3.8 plus 4.6 all divided by 5. So to solve for X, we'll multiply both sides by 5. I'm running out of room there, sorry. I'm multiplying by 5. So the left side, we end up getting 20.1 equals, and I believe the right side is going to give us, hopefully my math is correct, 15.6. I don't think my math is correct. I will type it in. 4.4 plus 3.7 plus 3.8 plus 4.6. 16.5. I guess I could have just tried adding them. I don't think I did that right. Hold on. 4.2 times... What is 4.2? Did I mess up my mean? 4.2 times 5. It's 21. That's where my math was wrong. That's why I use a calculator. So 16.5 plus X, we solve for X, so we subtract 16.5. So we end up getting X equals 4.5. There we go. Cool. So again, that problem, rely on the calculator. As long as we set it up, just use your calculator. Don't do mental math like I just did and mess up and then miss the problem because of that. All right. 3 more questions. So 36, what is the x coordinate of the x-intercept of the line with the equation 5/4 x plus 2/3 y equals 1 when it's graphed in the xy plane? So here they asked for the x coordinate of the x-intercept. So you and I have talked about the y-intercept, or I talked about the y-intercept already. X-intercept just means we're going to make y equal to 0. So we're just going to rewrite the equation but plug in 0 for y. So 5/4 x plus 2/3 times 0 equals 1. Well, 2/3 times 0 is just 0, so this just goes away. So now we have 5/4 x equals 1. So to solve for x, instead of dividing by 5/4, which you could, I'm just going to multiply by the reciprocal. So we get x equals 4/5. You could also put 0.8, so if you use your calculator, calculator gives you a decimal, that is fine as well. All right. So 37. 37 says, what is the perimeter of an equilateral triangle with a height of 5 square root of 3? So they're talking about a triangle. So they didn't draw it for us. So let's go ahead and draw a triangle. So I'm going to try to draw my best approximation of an equilateral triangle. That's not terrible. I think I could do better, but whatever. We'll say that. Okay. And then they said that it has a height of 5 root 3. So I'm going to draw that. I'll do it in a different color. So the height right here is going to be 5 root 3. That line is so bad. Let me redraw that. That would bother me. So 5 root 3. Why will it not just lock it as a right angle? Okay. So this, we just made a right triangle. Again, my triangle is not perfect. Yours does not have to be perfect, but I want it to be close. Well, this angle down here is a 60 degree because for an equilateral triangle, all of the angles are going to be 60 degrees. And then also all of the sides are going to be the same. Well, since that bottom right angle, is 60 degrees, and this angle right here is 90 degrees, that means this angle up here is going to be 30 degrees. So that means we have a 30, 60, 90 triangle. So we have to remember the side relationships of a 30, 60, 90. So the side ratio of a 30, 60, 90 is usually the short leg we call x. The long leg is usually x square root of 3. And then the hypotenuse we call 2x. It's just twice the short leg. So here, if we recognize the height was 5 root 3. Well, that looks exactly like x root 3. So that means x here is just 5. So that means that the hypotenuse of this triangle, that right triangle, is 10. Well, again, this is an equilateral triangle. We're trying to find the perimeter. So we figured out the length of one side. And since it's equilateral, all the sides are going to be 10. So when we do the perimeter, it's just 10 plus 10 plus 10. So the perimeter is just 30. So yeah, if we did not draw this triangle, this problem becomes much harder because it's hard to visualize that. Like, why would we instantly think that it's a right triangle or see that it would be a right triangle? So that's why drawing is so helpful. And again, I'm drawing it where I have the help of Notability to where it can make my triangle look a little bit nicer than if I drew it by hand. But draw it close enough. I mean, we roughly can draw an equilateral triangle and a right triangle and that sort of stuff. So try to draw it somewhat to scale. It doesn't have to be perfect, but it should be something where if you looked at it, you could see that somebody was trying to draw a right triangle or an equilateral triangle, something like that. All right, so 38. It says, in the system of equations shown, a is a positive constant, so a is a positive number. For which value of a does the system have exactly one distinct real solution? So I would notice this system, one of these is just y equals -3, so that is a line, it's a horizontal line. And the other one is a parabola. It's in standard form, y equals ax squared plus bx plus c. If you ever notice that you see a quadratic and they're talking about the number of solutions, we are meant to do what's called the discriminant. So the discriminant, real quick, is just this. The discriminant is b squared minus 4ac. And if that thing is greater than 0, you're going to get 2 real solutions. If your discriminant, so b squared minus 4ac, is equal to 0, you're going to get 1 real solution. And if b squared minus 4ac is less than 0, then you get 0 or no real solutions. So for this problem, they wanted to have exactly 1. So we're going to do this form. But in order to use that, we have to take this system and not have it still be 2 equations. We need it to be 1. So since they're both written as y equals, I can set them equal. So we're going to think of it as -3 equals x squared plus 10x plus a. But again, in order to get it written into our standard form, we want it to be equal to 0. So we're going to move this 3 over. So I'm going to add it over. So now we get 0 equals x squared plus 10x plus a plus 3. Okay. So now we have to determine what the a, b, and c are to be able to plug it into our discriminant. So again, I would write it. And here, this is where things get a little bit confusing. I'm going to do it in a different color again. Our a value is 1. So again, I'm getting that from this generic equation. 0 ax squared plus bx plus c. So what I'm calling a in blue is not the a value that I have in red. So then b here is 10. And then c is actually this whole thing. So now I'm just going to go and plug it up again into that equation right there. So b squared, so that's 10 squared, minus 4 times a, which is 1, times c, which is a plus 3. And this should be equal to 0. Because our discriminant told us that if we have one real solution, it should be equal to 0. So now we're just doing arithmetic. So it's 10 squared is 100. And then we just distribute, so it becomes minus 4a minus 12 equals 0. So we get 88 minus 4a equals 0. So we'll add the 4a over. We get 88 equals 4a. So we'll divide both sides by 4. So a is 22. Now for this problem, I do have it where students sometimes will do it a little different. They actually have the right idea in mind. They just don't actually use the discriminant. I personally teach as the discriminant, though. I think the discriminant is something that you are very likely to have to do on the test tomorrow and on most tests. It's not quite on every test, but it's on quite a bit. So again, if you ever see them talk about a quadratic, so a parabola, an x squared, and they're talking about the number of solutions for something like that, then it's going to be do the discriminant, which is the b squared minus 4ac. So yeah. All right. I know I didn't do every question in this test. I think I skipped the first 4 and then like the first 5 of the calculator. So we did 49 questions. Are there any questions? I think I have like 4 or 5 of you guys who are watching. One of them may be my sister. I don't even know. But are there any questions that you guys have from anything that I have done, haven't done, you're curious about? I don't know, anything you can think of that you think could help for tomorrow? There's not as many of you as thought maybe there would be. Yeah, somebody said I should put a picture of me, but I don't have a camera. I have a camera of me, but I don't have a camera. So I put an old picture of me from high school. That was me my senior year on senior night for soccer. So if any of you guys are curious why the picture. So that was young 18-year-old Hampton. No, I was 17 still. I turned 18 like 2 weeks later. So no questions from anybody? Which is fine. It's your last time to be able to ask something for the test tomorrow. Okay. Well, if nobody has any questions, then there's nothing else for me to show or do. You guys really know this stuff. Again, we can do quite well with the math. So yeah, so if you have questions, if any of you guys have my number, you can text me if you have a question. Or I'm probably going to leave this up so you guys can watch it again. So if there's a part that you have a question on or you just want to see again, you can rewatch the video. Yeah, you can text me or you can try to ask in the comments. I'll try to look at it somewhat the rest of today. And just see if there's anything that somebody asked, and then maybe I can try to explain it through a message or something. But I figured this would be very helpful for you guys. just to kind of help us with the remember some of those details before you take the real test. Yeah, and again, I'll probably leave this up potentially all the way up until the June test. And then maybe whatever further on after that. I know for a lot of you guys are wanting to be done. So hopefully you guys don't ever take this test again, but if not, this may be something you can use as a quick way to review. Especially if it's something where you're done tutoring, but you decide you're going to take it again. You can still always come back to this and watch it if it's something that I have up. All right. Well, good luck to everybody. Hopefully we get some 800s in the math. Yeah, just be confident. If you guys know the stuff that I went through today, you should be able to do quite well on the test. Yeah. All right, good luck.